Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is partitioning segments. It's a little mini lesson on page 410 and 411 in your textbook. So I just kind of wanted to go over a few of these problems. So the first one, we have a point A at 3/4. So we have our y and our x axes. All right, 1, 2, 3, go over to 3, then go up to 4, 1, 2, 3, 4, and that is point A at 3, 4. Point B is at 6, 10. All right, and what they want us to do is they want us to partition this segment into a ratio of 3 to 2. So if I want a 3 to 2 ratio, how many equal parts will I actually have? If I have 3 parts to 2 parts, how many total parts are there? 5, right? So 5 equal segments, 5 equal parts. All right, so right here we have a distance of 1, 2, 3, and 1, 2, 3, 4, 5, 6. All right, well 3, right? 3 divided by 5 equal parts is what? What is 3/5? 0.6? And 6 divided by 5 equal parts is 1 1/5, or 1.2. Okay? So to divide this up, every time I go up 1.2, I'm going to go over 0.6, right? Rise 1.2, run 0.6. Rise 1.2, run 0.6. So my coordinates, if I'm following this, rise, my 4 plus 1.2 is 5.2, plus 1.2 is 6.4, plus 1.2 is 7.6, plus 1.2 is 8.8, plus 1.2 is 10. 3 plus 0.6 is 3.6. 4.2. 4.6 plus 0.2 is 0.8. 4.8 plus 0.6, 5.4. Plus 0.6 is 6. And we're now up to this number, right? We started here, we got to here, following this pattern. So now let's plug in these points. 3.6, 1, 2, 3.6, comma, 5.2. 1, 2, 3, 4, 5.2, somewhere around there. 4.2, comma, 6.4. 4, 5, 6.4-ish. 4.8, 7.6. 1, 2, 3, 4.8. 1, 2, 3, 4, 5, 6, 7.6. 5.4. 1, 2, 3, 4, 5.4. 8.8. 1, 2, 3, 4, 5, 6, 7, 8.8. And then 610. So these segments should all be equal. If I'm partitioning it into a 3 to 2 ratio, 1, 2, 3 segments to 1, 2 segments. This point right here is where it gets divided. So this is our initial point. This is our next point. That's right there. Right there. So this is our 3 to 2 ratio. And our answer is right here. Do you guys see how I did that? Let's try another one. All right, so our A is at 1, 3. Our B is at 8, 4. All right, so, and we are going to partition this into 4 to 1. 4 plus 1 is what? So 5 equal parts. All right, so our height is 1. 8 minus 1 is 7. So our height of 1, we're dividing by 5 equal parts, that's 0.2. We're going up 0.2 each time. And then we're running how much? 7 divided by 5 equal parts, which is 1 and 2/5, or 1.4. So this is our rule, like what we're going to end up doing to each number. So we're starting at 1, 3. All right, so my 1, I'm going to be going over 1.4, so I'm adding 1.4 to it. So I'm at 2.4 plus 1.4, 3.8 plus 1.4, 4 point what? 3.8, 4.8, 4.9, 10, 11, 12, 5.2. Plus 1.4. 5.2 plus 1.4, 6.6 plus 1.4 is 8. So we know we got up to the right number, so we know we didn't make any silly mistakes. On our 3s, on our height of 3, we're going up 0.2 each time. So 3.2, 3.4, 3.6, 3.8, 4.0. 8.4 is where we're supposed to end, so we know we didn't make any silly mistakes. So if these are our partitions, where would we be? 4 to 1. 1, 2, 3, 4 to 1. So you could plot all these to show it, or you can just plot 1, 2, 3, 4, 5, 6, 0.6, comma, 1, 2, 3.8. And this is where we divide into our 4 to 1 ratio. And you could show where all these other points are. That's totally fine. Do you guys understand how I did this? Are we okay? Do you want to do one more? All right, so let's do another one. All right. A is at negative 2, 1. B is at 4, 5. And we have a 3 to 7 ratio. Add them together, 10 equal parts, right? We're starting here. All right, so our height, we have a height of 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, so our height of 4 is getting divided into how many equal parts? 10. 4 divided by 10 is 0.4 up each time. And then in talking about left and right, we have 6 divided by 10, which is 0.6 over each time, right? So these are our rules. So we'll do the 0.6 part first. So negative 2 plus 0.6 is negative 1 point what? Negative 1 point what? If your brain is hurting, 2 negative plus 0.6, 1.4. Negative 1.4 plus 0.6, negative 0.8 plus 0.6, negative 0.2 plus 0.6, 0.4 plus 0.6, 1 plus 0.6, 1.6 plus 0.6, 2.2 plus 0.6, 8 plus 0.6, 3.4 plus 0.6, 4.0, which is our final one. So we know we're good. Now let's do the other side. We're starting with 1, and we're going up, right? This is our x. This is left and right. This is up and down. We're going up 0.4 each time. 1.4, 1.8, 2.2, 2.456, 3.0, 3.4, 3.8, 4.2, what am I going, 6? 4.8. What did I mess up? Was I doing 0.6, or did I forget what I was doing? Did I change? See? Look, if I didn't get to 5, so I know I screwed something up, and I think my brain switched during it. So I added 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4, 0.4. This should have been a 6 if I was adding 0.4, but my brain went to 0.6, and I knew I messed something up. See how this helps you know if you screw up? 4.6 plus 0.4 is 5.0, which gets us to where we want to be. So it has that extra like built-in like correction when you do your work like this, which is awesome. So if I'm doing 3 to 7, 1, 2, 3 to 1, 2, 3, 4, 5, 6, 7, this separates it in 3 equal segments to 7 equal segments. So at negative 0.2, 1, 2.2, that would be your split for your 3 to 7 split. This is 3 versus 7 of the distance. 3 parts to 7 parts. So if you actually put in all these dots, you'd have 3 segments here. So there's 2 dots within here. You'd have negative 2, comma 1, negative 1.4, 1.4, negative 0.8, 1.8. Right? So you have 1, 2, 3 segments. And then 7 segments fit in here if you actually add in all those dots. Does that make sense? And that is how you partition segments. I hope you guys enjoyed today's lesson. It was a quick little mini lesson on page 410 and 411 in your textbook. Please like and subscribe and have a fantastic day.